So today I cannot explain another question in another language, so I'll be doing another optimization question. I'll be doing question 45, which is the velocity of a wave length L in deep water. So for this question, you're given that V equals K to the square root of L over C plus C over L, where K and C are positive constants. So K and C are constants, meaning that they are actual numbers and not any variables. And they are asking what is the length of the wave that gives the minimum velocity. So in order to find the minimum velocity, you have to differentiate this equation and set it to 0 and solve for your variable, which is L, which is, in other words, the length of the wave as it is stated in the opening sentence. So here's your equation. V equals K into square root of L over C plus C over L. The square root is the same as to the power of a half, and from here we can differentiate using the chain rule. Differentiating using the chain rule will give us V dash equals a half K into L over C plus C over L, all to the negative half, which is when you minus the 1 from half, times by the inner function, which is 1 over C minus C over L squared. We then set our first derivative to 0, and then we solve for our variable being L. As you can see, when you times out the function, you end up with two different parts. So you can take this part across to the other. Sorry, the recording cut out before. So carrying from the previous video, you can see that when you take this across to the other side, you end up with two sides with common variable, with common factors, which you can cancel out. So on the left hand side and the right hand side, you can cancel out k's, you can cancel out the 2's, you can cancel out the whole bracket as they are the exact same on both sides, and then you are left with C over L squared equals 1 over C. You then solve for your L squared equals C squared, square root both sides, and you get L equals C.